now we're putting the ideas together. Again, you've seen this already. The first thing I'm going to get you to do here is, with this minus k on this side, are you okay, or can you understand what I did when I wrote it as plus k on the other side? I just moved the k over, but we're going to feel more comfortable if the y is by itself and everything else is on the right. And what this box is trying to show us is whatever is inside the function, that moves it horizontally. The k outside of the function, that's going to move it vertically. This is in function notation. I don't know if you want to put an arrow here and label that as horizontal, and an arrow here and label that as vertical. But what's inside the function is horizontal. What's outside of the function is vertical. And so in this one here, they're telling us y equals f of x, the red equation, and they give us the equation as negative x to the 4. That isn't a parent graph that we looked at. In fact, it's a little bit more of a complicated graph. We've got a negative involved and an x to the 4. Whereas all of our original parent graphs are like just x cubed, just the square root of x. Okay? And they want us to graph, in blue, y minus 4 equals negative x minus 2 to the 4. So the first thing I'm going to do is I'm going to take that equation and move that 4 over. Negative x minus 2 to the 4 plus 4. And now I'm going to compare my blue equation to my red equation and say, what's different? What's changed? Can you see there's a negative in front of both of them? That hasn't changed. The only things that have changed is now there is a minus 2 and a plus 4. That minus 2 is inside the function. The plus 4 is outside of the function. Yes. It's already graphed. Yeah. So this is just part of your notes part to help understand. Then we'll go to example 2 and do one. So when we see this, and when I rewrite this as this, I'm going to need to move it 2 to the right and 4 up. And you're right, this is already on your function on your graph, but can you see how that's happened? 2 to the right and 4 up. The negative in this example is ignored. Later on, we're going to find out what negatives do. I mean, what happened with the negative with a parabola? You already know this. It flipped down, right? So if you took away the negative from this x to the 4, it would have been sort of like a big parabola opening up. That negative flipped it down as well. And we're going to learn negatives this afternoon, what they do. But sometimes they give you the original graph with stuff already done to it, and you have to translate it or move it even further. So going to an example 2. Here's the graph of j of x. Okay? A couple units from now, you'll know that that's a polynomial graph of degree 4. But right now, it just looks like a w, and that's fine. So we've got a w graph that they call j of x. They should have called it w of x, but whatever. Sketch the image after a translation of 4 units left and 5 units down. So one of the things that you would do is you would say, what are sort of key points? Those look like key points to me. And if I went 4 units to the left, 1, 2, 3, 4, and 5 units down, 1, 2, 3, 4, 5, that point would be there, 1, 2, 3, 4, 1, 2, 3, 4, 5. Those are our bottom 2 points, and this one, 1, 2, 3, 4, and 5 down would be there. And then make sure I add my arrowheads on the end of my graph. I have moved it 4 units left and 5 units down. So I start reading my question again. Here's a graph of j of x. Sketch the graph, the translation, did that. Write the equation of the image graph in terms, here it is again, as my highlighter is working, in terms of the function j. So what does that mean? I want to write an equation, y equals, and then on the right-hand side of that equation, I need it in terms of the function j. So I have to think, well, I'm going to have the function j. Did I have any movements left and right? Because that happens inside the function. Yes, I moved 4 to the left. That shows up as x plus 4 inside my equation. Because we remember that inside the function, it's opposite. So 4 to the left would be a plus 4. And then 5 units down, that would happen outside of the function afterwards, minus 5. Okay? I've now done the write the equation, state the domain and range of each function. So my original one, I do my original in red because it's in red. You can probably do your original in black because that shows up in black in your notes. My domain of my original one, if there were arrowheads on the end, can you see that it continues to get wider and go up forever? So because of that continuing to get wider all the way, there's no minimum x value, there's no maximum x value. In interval notation, we would say it goes from negative infinity to infinity, or in set notation, x is an element of all the real numbers. For our red function's range, does it have a minimum value? Yes, at 0, and 0 is included, but it has no maximum value, so we say y, 0, square bracket, 0 to infinity. In set notation, we would just say that y is greater than or equal to 0. Technically, that's shorthand set notation, but they're no longer really fussy about the proper set notation, but I'll show it to you. Proper set notation starts off with a fancy squiggle bracket. It starts off with the variable you're defining, y. Then they draw a straight line such that, there, mathematicians like to cut down words. So like, ooh, what could we do instead of having to write such that? Let's just write a big, long, straight line. Y such that y is greater than equal to 0 where y belongs to real numbers, fancy squiggle bracket in the end. Okay? When I went to high school, you had to write set notation properly every single time. And so I liked interval notation a lot better. Interval notation is kind of like how you would say something in English, short and to the point, and like set notations like French, where like it's extra long. Like French words, you don't even have to say the last half of the word, right? Just, so they have all those extra letters that they write that they don't even say. So I always considered set notation to be like the French form and interval notation blunt. That's like the English form. And now our domain and range of our blue function, okay? What's happened? It's been moved 4 to the left. Can you see that only the horizontal stuff would change your domain? But since your domain was everything, moving it something that's everything left and right is not going to affect its domain. It's still going to be negative infinity to infinity, or x is an element of the reals. But your range will get changed because you've moved it down 5. So now it's starting at negative 5 and going up to infinity. Or y is greater than equal to negative 5. Okay, questions for practice? 8, 9, and 10.